Hi, everyone. We have been talking about electromagnetic induction. So let's talk a little about this and the process of generating electrical power for the national power grid. Most of the electricity generated for the United States and most countries across the world are generated using electromagnetic induction. There are a few other sources. Solar, of course, is a method of generating power that's becoming more common. And that is one of the few that is different. But most of the plants that are out there are going to turn whatever source into electricity, which is that flow of electrons using electromagnetic induction. So how does this work? This is a grand picture. This is inside of Hoover Dam. I remember going to that as a kid and going, it's a dam. How exciting can it be? But it was really quite fascinating. These are the large turbines inside of the power plant down underneath that dam, and it gives you a sense of scale. Here is a person walking next to them, and these are the big rotating coils around them. These are the large coiled magnets, and these spinning turbines are what generate the electrical power. Now, in production of commercial power, there's always a source of energy, and there are two common sources, the renewable and the non-renewable. So very often we use fossil fuels. By fossil fuels, things that used to be alive, and that is coal, oil, and natural gases. And these things are typically all burned to generate heat. Another thing that is used to generate heat is nuclear power. So we're referring to uranium, sometimes plutonium. Plutonium is spent fuel rods that have been refurbished, very often from military purposes. But uranium comes in, it is processed to have little pellets. They are then packed to be in fuel rods, and this is a uranium fuel assembly that is used. But all of these are used to produce heat, and that heat is used to produce steam, and that steam is used to turn those large turbines that we saw. There are renewable, also referred to as clean sources of energy, and we're looking for something that is going to transform one kind of energy into another. Well, waterfalls, or holding water behind a dam and then letting it flow through a collection of turbines, have been used for well over 100, and I'm not quite going to say 150 years, but almost. Niagara Falls has a power plant, one of the largest and first commercial power plants that was ever produced in the United States. Water, as it falls over those turbines, causes that rotation of those electrical coils through a magnetic field. Hoover Dam, there are channels that make the water go through those turbines, which I showed you that picture earlier. Wind power, the actual turbines are up here next to the propeller. The heating and cooling of Earth's atmosphere, which is done by our glorious sun, that generates the electricity. Tidal power, I think, is very nifty. Works well if you are near the oceans and you have extreme tides. Tidal power is actually powered by gravity, gravitational attraction between the sun, moon, and of course our lovely planet Earth. Causes water to rise when the moon and the sun are closer, and when they are not directly above us, those water levels are going to fall and those tides are going to rush in or rush out. All of that motion, again, turning blades, propellers, and we've got kinetic energy that will then be transformed into electrical energy. Whatever kind of electrical generator you are dealing with, you're going to have big turbine blades. Now, if it is a steam-powered generator using one of those fossil fuels or nuclear power that's going to generate heat, I don't care if it's a nuclear reactor or a coal-burning plant. It's nothing but a big fat tea kettle. It is burned being burned to make steam, and the steam is sent through to rotate those turbine blades. You just want kinetic energy by that moving steam, and that steam is going to rotate those turbine blades. The turbine blades is attached to a large axle. The axle is then going to spin a large coil of wire inside of a large magnetic field. If you have a moving conductor inside of a magnetic field, you are going to get the production of electric current. That is what electromagnetic induction is all about. If you have an electrical power plant that is very often, especially if there are one of those that uses heat as a source of power, meaning fossil fuels or nuclear power, very often they are going to be near some sort of a natural water source. And the reason is there's so much heat that is used to create the steam that's used to turn the turbines that they have to cool the system back down into liquid water from steam in order to start the process over again. And so they do this near rivers and lakes. Most major lakes and rivers in the United States are going to have power plants located next to them because it's a very large source of water. One of the telltale signs of a power station is going to be cooling towers. And cooling towers, what's going on in here is literally it's raining. They pump the water up and then they let the water fall down as rain. The stuff that's coming out that looks like big fluffy clouds, that's exactly what it is. It's raining here. They're using the latent heat of evaporation as the and the cooling effect of evaporation. As the water falls, it is cooling. The heat is lost during that evaporative process, and it's cool enough to be put back into the lakes and the streams. There's a lot of environmental laws that require that the water taken out of the lakes and streams compared to going back in. I'm not sure of the exact number, but last time I looked, it was 4 or 5 degrees Fahrenheit difference between what comes in compared to what goes out. And my fishermen friends tell me it's great fishing around one of these power plants because the fish like the warmer water. Again, we use water for cooling because it has that very high specific heat, and it is great at absorbing lots of heat before it changes state. So electromagnetic induction powers the life that we live. It is a wonderful thing. All right, we will talk to you later.